Hey, welcome back. In the last video, we loaded the texture for the nebula sprite sheet. Now in this video, we're going to create the nebula variables we need in order to draw the sprite to the screen as well as move it across the screen. This means we're going to have to create a rectangle to specify which section of the sprite sheet we want to draw at any given point in time, and we also need a vector2 for the position that we'll use to draw the nebula sprite on the screen. We're going to also create a velocity for the nebula so we know how fast to move the nebula on the screen. You're then going to be challenged with freezing Scarfy's animation while Scarfy is in the air so that the running animation is only played while Scarfy's on the ground. Let's go ahead and get started. So we have our texture 2D nebula. It's now time to create the rectangle and the vector 2 just like we did with Scarfy. So let's create the rectangle. We can call this rectangle nebrec, short for nebula rectangle. Now when it comes to these special types that have their own variables, we can initialize them on the same line just like we do using braced initialization with other variables. We do so using the braces, and inside the braces we put a comma separated list of values to initialize those variables contained within the rectangle type. Now the order matters, so we need to pass in the values in the correct order. If you right-click on the rectangle type and select Peak and Peak Definition, we get a pop-up window inside the Raylib library showing us the definition of this rectangle type. Now you don't need to worry about all the syntax that you see here, but you can see the different variables declared inside the rectangle type and the order that they're in. You'll see that these are all floats, and they're x, y, width, and height in that order. So we can initialize these in this order. Let's go ahead and close out of that pop-up window. Now let's initialize nebrec with some values. Remember, it's x, y, width, and height. For x and y, I'm going to initialize this with values of 0.0 for each one. Now for width, we need to get the width from the nebula texture 2D. Now take a look at how we got the width from the Scarfy texture 2D when we initialized scarfyrec.width. We divided by 6 because Scarfy's sprite sheet has 6 images across, but remember, the nebula sprite sheet is an 8x8 sprite sheet. So what are we going to initialize the width of our rectangle to? You probably guessed we're going to get our nebula texture 2D and use the dot operator to access the width. And from there, we're going to divide by 8 since this is an 8x8 sprite sheet. So the width of a single nebula sprite is the nebula texture sprite sheet dot width divided by 8. Now, how are we going to initialize the height? You got it. We're going to take the nebula dot height and divide that by 8. So now we've created a rectangle called nebrec, and we've used braced initialization to initialize it on the same line that we declared it. So not only does this save us room, since we didn't have to take 5 lines of code to initialize this nebula rectangle, but the nebula rectangle is never uninitialized. We initialize it with valid values from the start. Next, we need a position, and this is going to be a vector 2. We're going to call this nebpos for nebula position. We can go ahead and initialize this on the same line as well. And just like we did with rectangle, we're going to right-click on vector 2, go to peak and peak definition, and now we're seeing the definition for the vector 2 type. The vector 2 is even more simple than the rectangle. It has 2 variables, both of float type, called x and y in that order. So let's close out of that pop-up and initialize nebpos with values for the x and y. Now, if we want our nebula to start off to the right of the screen, just off the screen, we can give the x coordinate a value of window width. And for the y, if we want our nebula on the ground, what does our y need to be? That's right, it's going to be window height minus nebrec.height. Now we want our nebula to be floating across the screen from right to left, which means it'll be moving in the negative x direction, so we need a velocity. Let's create an integer called nebvel for nebula velocity, and it's going to be a negative value. Now let's give this a value in pixels per second rather than pixels per frame, so we can use delta time to make this movement frame rate independent. I'm going to give it a value of negative 600. And let's give this a comment, nebula x velocity, and in parentheses we'll say pixels per second. Now we have our variables set up and we've loaded the nebula texture. We're now ready to draw the nebula and update its x position. So let's go all the way down to where we're drawing the Scarfy rectangle. And let's comment this draw texture rec call to say draw Scarfy. And just above that, we'll add another comment and say draw nebula. And just like we did with Scarfy, we're going to call draw texture rec. Go ahead and type in the draw texture rec function call and pass in the correct variables. Excellent job. So we're going to do draw texture rec, and the first argument is a texture 2D. We're going to pass in nebula. Next, we need that rectangle. We're going to pass in nebrec. Next is the position. That's a vector 2. We're going to pass in nebpos. And for the color, we're going to use white since we don't want to tint this with any color. Now the nebula starts off just out of view to the right of the window, so we need to update the nebula's x position. Let's scroll up to where we're updating the Scarfy position, and we can update the nebula position just above that. Now I'll change the comment for updating Scarfy's position to update Scarfy position, and we'll create a new comment above it that says update nebula position. Now here we can update the nebula position. So we need to get that nebula vector 2 variable, nebpos, and we're going to access the x from nebpos in order to move the nebula across the screen in the x direction. Now we can add to nebpos.x with the plus equals operator and use the nebula's velocity. That's going to be nebvel. Now we need to multiply by dt, which is delta time, to make this movement frame rate independent. All right, let's go ahead and see how this works by hitting run and start debugging. And there it goes. It flew by pretty quickly. Now these are hazards, so Scarfy is going to want to jump in order to get out of the way of each nebula. Now notice when Scarfy jumps, his running animation is still playing. So that's something that we want to fix. So here's your challenge. You're going to freeze Scarfy's animations, and you're going to use the isInAir variable to know when Scarfy's running animation should freeze. We know that isInAir is true when Scarfy is in the air and false when Scarfy's on the ground. So if isInAir is false, go ahead and update the animation frame using the code we already have in place. Otherwise, don't update the animation frame at all. Go ahead and pause the video and do this now. All right, we're back in Dasher.cpp. Now I'm going to go down to where we're updating the animation frame. And we're checking to see if running time is greater than or equal to update time, which is 1/12 of a second, at which point we reset running time and then update the animation frame. But we can stick all of this into an if check because if we're not even on the ground, we don't need to do any of this. So just above update running time, I'm going to place an if check and check to see if we're not in the air. We can use the negation operator with isInAir. And I'm going to copy all this code and move it into the if check. And I'll go ahead and highlight it and tab to indent it. Now, if is in air is false, we can update the animation frame. Otherwise, we do nothing. Let's go ahead and hit run and start debugging. Now notice that Scarfy freezes whenever we're in the air. So whichever animation frame Scarfy was on, when we jump, that's the animation frame that Scarfy gets frozen to. So in summary, we've loaded a texture for the nebula hazard just like we did with the Scarfy texture. Now this was a sprite sheet, so we had to get the width and height of a single sprite by dividing that sprite sheet's width and height by 8, since this is an 8 by 8 sprite sheet. We set up nebula movement, which means we created a rectangle and a position, as well as a velocity that we used to move the nebula across the screen. We also froze Scarfy's animation while in the air so that Scarfy doesn't continue running while flying through the air. Great job! In the next video, we're going to work on animating the nebula hazard. I'll see you then.